We all know the name Einstein, right? But what do we really know about the mind that completely redrew our map of the universe? It all started with a few simple, yet world-changing questions.
What if time wasn't this constant ticking clock that we all experience in the same way?
And what if the very fabric of reality around us could actually stretch and warp?
And what if something solid was just a really concentrated form of energy?
These sound like ideas straight out of science fiction, but they were the very real questions one man dared to ask. And the answers he found, well, they changed everything.
So who was this person? He wasn't some tenured professor at a grand university, at least not at first. He was an outsider, a patent clerk with a bit of a rebellious streak and an absolutely incredible imagination.
For over 200 years, physics was dominated by Isaac Newton. The universe was seen as this big, predictable machine, where time was absolute. It just flowed the same for everyone, everywhere. But Einstein started with this simple, almost childlike question. What would you see if you could ride alongside a beam of light? That one thought experiment began to unravel the entire way we saw the world.
And what's really incredible is where these revolutionary ideas were born. Not in some prestigious university lab, but in a Swiss patent office. After struggling to find an academic job, Einstein took a post reviewing inventions. And he later said this isolation was a blessing. It gave him the freedom to think without the pressure to conform to what everyone already believed.
And that freedom led to one of the most remarkable bursts of creativity in the history of science. Let's look at the year 1905, his Annus Mirabilis, or miracle year.
At just 26 years old, he published 4 separate papers, and each one was a pillar of modern physics. First, he explained the photoelectric effect, a revolutionary idea that showed light could act like a particle, totally challenging the belief that light was only a wave. Next, he proved atoms were real by studying the random motion of particles. And then came the 2 bombshells. He introduced the theory of special relativity, and with it, the principle of mass-energy equivalence. 4 world-changing papers, all in a single year, while working as a patent clerk. Just incredible.
So what did these ideas actually mean? Let's break down how Einstein fundamentally reshaped our understanding of reality itself.
Special relativity introduced this really radical idea. Space and time aren't 2 separate things. They're woven together into a single 4-dimensional fabric he called space-time. And according to Einstein, the one unbreakable rule in this fabric, the ultimate speed limit, is the speed of light.
And this leads to one of the strangest consequences: time dilation. Imagine one twin stays on Earth while the other travels through space at nearly the speed of light. When the space-traveling twin returns, they will be younger than their sibling. Why? Because the faster you move through space, the slower you move through time. This isn't just a theory. It's been experimentally verified.
From his work on special relativity came this, arguably the most famous equation ever written. Just 3 letters and a number that unlock the secrets of the atom.
So what does it mean? It means energy equals mass times the speed of light squared. Essentially, mass is just a highly concentrated form of energy. They are 2 sides of the same coin.
The implications are immense. That little c squared is a huge number, meaning a tiny amount of mass can be converted into a tremendous amount of energy. This is the principle that explains the power of the sun and, for better or worse, the power released in nuclear reactions.
But Einstein wasn't done. A decade later, in 1915, he tackled the biggest force of all, gravity. And once again, he threw out the old rulebook.
Newton saw gravity as an invisible force pulling objects toward each other. Einstein's view was far more elegant. He proposed that gravity isn't a force at all. It's simply the effect of mass and energy warping the fabric of space-time. As the physicist John Wheeler famously put it, space-time tells matter how to move, matter tells space-time how to curve.
Think of it like this. Place a heavy bowling ball onto a stretched rubber sheet. The sheet curves. Now, if you roll a marble nearby, it won't travel in a straight line. It'll follow the curve created by the bowling ball. That's not a pulling force, it's the geometry of the surface. In Einstein's universe, Earth orbits the Sun because it's simply following a straight line through the curved spacetime created by the Sun's immense mass.
This radical theory was put to the ultimate test in 1919. Einstein predicted that the sun's massive gravity would actually bend the fabric of space-time enough to alter the path of starlight passing by it. During a solar eclipse, expeditions confirmed it. The positions of distant stars appeared shifted. Einstein was right, and overnight he became the most famous scientist in the world.
But these theories weren't just abstract ideas for blackboards. They have a profound and practical impact on the technology we use every single day.
The GPS in your phone has to account for relativity, both special and general, to work accurately. Without his theories, we couldn't understand black holes, the expansion of the universe, or gravitational waves, which we only detected in 2015. And here's a fun fact. He won his Nobel Prize in 1921, not for relativity, but for his 1905 paper on the photoelectric effect, which helped launch quantum mechanics.
Beyond the science, he was also a profound humanitarian. Robert Oppenheimer, who knew him well, chose the Sanskrit word ahimsa, meaning harmlessness, to describe his entire attitude toward human problems.
And perhaps this famous quote sums him up best. For Einstein, the ability to imagine, to visualize, to ask what if, was the true engine of discovery. It was the key that unlocked the universe.
He showed us that reality is stranger and more wonderful than we can imagine. He didn't just give us new answers, he gave us entirely new questions to ask. Which leaves us with one final thought. What's the next question that will change everything?